Hello, you're welcome back. All right, so we're going to be looking at trigonometrical identities. Okay, so now what are trigonometrical identities? Now, trigonometrical identities are function. All right, they are trigonometrical function that actually connect one or two trigonometrical ratios. Okay, now connect one or more. Please pardon me. Okay, so when you have a relationship that actually connects the ratios that we've already treated. We have the sine, we have the cos theta, and we have the tan theta. These are the three basic trigonometrical ratio that we treated. Okay, so an identity is actually the function or the formula that actually establish relationship between these ratios. Okay, so we are gonna look at them, and basically what you be asked to do in trigonometrical identities is to prove, okay, an identity. There are different identity. Of course, you get to prove the identity, and of course, uh, you prove the identity, the basic identities, and that there are some other extended identities that you might be asked to prove in examination. So we're going to be looking at them in this particular video. Let's start with the very first one. The very first identity we are going to establish or we want to derive. Okay, we're going to derive it from Pythagoras rule. Of course, you know very well that from Pythagoras rule we have that c square is equal to a square plus b square. Okay, so now, all right. So we are going to actually prove a derive, okay, an identity from this. How do I do that? Okay, I'm going to divide. I'll start by dividing through. I want to divide through by c square. Okay, so I have to. I'm going to divide everything here by c square. So I'll divide c square by c square. Then equal to else I'll divide a square by c square. Then I also have to divide b square by c square. Of course, you can see that c square cancels c square, okay? I'm left with 1. Then I have a square divided by c square, which is same as a all over c all square. Then plus b all over c all square. All right, so now a all over c is a ratio, okay? A is adjacent, y is the hypotenuse, okay? Adjacent all over hypotenuse is cos. So that's going to be cos theta. Cos theta all square, that's going to give me cos square theta. Don't forget I have 1 here. Then plus b all over c. B is my opposite, y c is my hypotenuse. B all over c is sine. Okay, so sine theta square will give me sine square theta. All right. So this actually shows that the first identity that we have derived is the sum of sine square theta and the cos square theta. Okay, is equal to 1. So that's the very first identity that I have actually derived. The very first identity that I have derived. Okay, now before I derive the next identity, I'm going to derive it from this. Okay, there is a particular an identity, okay, that I don't want to derive. I don't have to derive that. So the identity actually states that tan theta, the tan of theta, is equal to sine theta all over cos theta. Of course, you can prove that using this right angle triangle. Okay, I can prove that. Tan theta is equal to sin theta all over cos theta, right? So now let's prove if that is true. If sin theta all over cos theta is equal to tan theta, let's do that. Sin theta from here, you know very well that is going to be equal to opposite all over hypotenuse C. Okay, in a bracket, then all over cos theta. What's my cos theta? My cos theta is adjacent all over hypotenuse. That is A all over C. So as you can see, C is the common denominator. It will actually cancel out. So I'm left with that. Okay, please pardon me. Um, pardon me. All right, so C cancels out the denominator cancel. I'm left with B all over A. And you know B is opposite and A is adjacent. So opposite all over adjacent, you know already that that is tan theta. All right, so that is the proof. So sin theta all over cos theta is always tan theta. All right, having gotten that, known that proof now, let's actually look at the next identity from this. Okay, so the next identity I'm gonna derive it by dividing. I wanna divide everything in that first identity. Divide through. I wanna divide through by cos theta. By cos square theta, please pardon me. I want to divide through by cos square theta. So we simply mean from this identity now, sine square theta, I divide it by cos square theta. Then plus, I'll do the same to this. Cos square theta, I still divide by cos square theta. Then of course, I'll do the same to 1. 1 divided by cos square theta. So of course, you know that cos square theta cancels cos square theta. I have 1 here. So I'm going to have sine square theta all over cos square theta. You know that sine theta all over cos theta is tan theta. So the square of it. So this yields tan square theta. Okay. So sine square theta all over cos square theta is tan square theta. Don't forget that sine theta all over cos theta is tan theta. So that simply means that sine square theta all over cos square theta is tan square theta. All right. And of course, this is plus 1. And 1 all over, remember the inverse. Inverse of cos square theta is cosec square theta. Okay, so that is the inverse. Cosec square theta. All right, so this is another identity. So it's either I write it this way: tan square theta plus 1 is equal to cos square theta, or I will take this tan square theta to the other side. So I can write it this way: cos square theta then minus tan square theta is equal to 1. Please take note of that. So I will call this okay, this is identity number 1, identity number 2, this is identity number 3. Identity number 3. Okay, so I can now go further to derive identity number 4. All right, I will still derive that identity number 4 from my first identity, which of course is sin square theta plus cos square theta equal to 1. So this time around now, I'm going to divide I'm gonna divide through, okay, by sine square theta. All right, so that simply means that sine square theta I divide by sine square theta, then plus cos square theta I divide by cos square theta equal to 1 all over I divide by sine square theta. This cancels, okay, so I have 1. Then of course, please pardon me, divide by sine square theta, divide by sine square theta. So this cancel, cos square theta all over sine square theta is the reciprocal. This is some because this is the inverse of tan. Remember, tan is sine all over cos, but now this is the inverse. So this is the inverse of tan. This is the inverse of tan square theta. 1 all over tan square theta. Okay? And of course, 1 all over sine square theta. So now let's look at the inverse. What is the inverse of tan? The inverse of tan is cot. So this cot square theta. And the inverse of sine, please pardon me, I made a mistake here. Okay, the inverse of cos square theta is sec square theta. Please pardon the mistake, I made a mistake here. All right, is sec square theta. Please pardon that mistake. And the inverse of so that simply means that here now I'm supposed to have sec square theta, sec square theta. Okay, sec square theta. All right, so the inverse of sine. Okay, so we have cos sec square theta. So which simply means that if I should rearrange this, I will now have that cot square theta, cosec square theta, please pardon me, cosec square theta minus cot square theta is equal to 1. Okay, so now this is gonna be 4 now. Identity 4. So let's take them one after the other. The very first is sine square theta plus cos square theta is equal to 1. Please take note of that. Second is tan theta is equal to sin theta all over cos theta. Tan theta is equal to sin theta all over cos theta. Then the third is sec square theta minus tan square theta is equal to 1. Sec square theta minus tan square theta is equal to 1. Please take note of that. While the last is cosec square theta all over minus cot square theta is equal to 1. So these are the basic trigonometrical identities. All right, so we're going to be looking at some questions, okay, that we are going to solve using these trigonometrical identities, and that will be in the next video. All right, see you in the next video. Thank you very much.